Hey everyone, we're about to tackle something that can look, well, pretty scary at first, polynomial division. But I promise by the end of this, you'll see it's a puzzle you already know how to solve. Okay, let's just jump right in. You see a problem like this, and yeah, I get it. With all those numbers and letters and these little exponents all mixed together, it's easy to feel a little overwhelmed. But here's the thing, and I really mean this. You already know how to do this. Seriously, if you can do basic division, you've totally got this. We're just adding one tiny little twist.
So let's start with something you already know really well. See, at its heart, polynomial division is just, well, it's just division. It just has a few letters thrown in for fun.
Just look at this comparison. On the left, you've got 21 divided by 7 is 3. We've known that since, what, 3rd grade? Now look at the right. It's pretty much the same problem, isn't it? It just has the letter M hanging out. The numbers part, it works the exact same way. The only new piece of the puzzle is figuring out what to do with those letters.
And that brings us to the one simple rule you need for the letters. It's called the power rule. All it means is that when you multiply variables, like m times m, you just add their little powers together. So m to the power of 1 times m to the power of 1 gets you m squared. That's it. That's the secret to the whole thing.
Okay, so now that we've got that one rule down, let's see how we can turn this into a super simple, repeatable process, a method that's going to work for any polynomial division problem you see, no matter how crazy it looks.
And believe it or not, the entire process is just 3 easy steps. Step 1, focus on the first term. Step 2, multiply the divisor to match it. And step 3, subtract and bring down the next term. Then you just repeat. Focus, multiply, subtract. That's the loop.
All right, talking about it is one thing, but let's actually see this method in action. We're going to put our 3-step method to work and solve a problem together from start to finish.
Okay, here's our practice problem. We're dividing 8p cubed minus 4p squared by 2p squared. This is the perfect problem to see our 3-step loop do its thing.
All right, first things first. Step 1, focus. This is so important. We are going to completely ignore that minus 4p squared for a minute. Just pretend it's not even there. Right now, our entire world is just that first term, 8p cubed, and what we're dividing by, 2p squared. That's it.
So let's break that question down. First, the numbers. How do we get from 2 to 8? Easy, we multiply by 4. Now the letters. How do we get from p squared to p cubed? Well, remember our power rule? We just need to add one more p. So we multiply by p. Put them together and what do you get? 4p. That's the first part of our answer.
Okay, now for steps 2 and 3. We're going to multiply our answer, 4p, back by the divisor, 2p squared. And what does that give us? 8p cubed. Perfect. Now we subtract. 8p cubed minus 8p cubed is 0. Awesome. First loop is done.
But we're not finished, right? Now we get to bring down the next piece of the puzzle, that minus 4p squared that we've been ignoring.
And guess what we do now? We start the whole process over again. We're right back at step 1, focus. But this time, we're focusing on our new term, minus 4p squared.
And hey, check it out. This time it's even easier. Look at the variable part, p squared. It already matches, so we don't need to worry about the letters. We just need to turn the number 2 into a negative 4. So we multiply by negative 2. So we multiply that negative 2 by 2p squared and subtract, and we're left with 0. And there's nothing left to bring down. We're done. The stuff we have on top, the 4p and the minus 2, that's our final answer. The quotient is 4p minus 2 with a remainder of 0.
So that last one was nice and neat. It worked out perfectly. But, that's not always how it goes, right? In math, just like in life, things don't always divide so cleanly. So what happens when you have leftovers?
Let's take a look at this new problem. A little bit longer, a little more going on. And spoiler alert, this one is not going to end with a nice clean 0 at the bottom.
Now, if we go through our same exact 3-step process, focus, multiply, subtract, bring down, we eventually get to this point. We've got a quotient up top, 5m minus 3, but then we have this stuff left over at the bottom, 10m plus 8. This is our remainder. But the big question is, how do you know when you're supposed to stop?
Well, luckily, there's a really simple rule for that. You stop the whole process as soon as the power of your leftover stuff, the remainder, is less than the power of the thing you were dividing by, the divisor.
Let's see how that works with our example.
The divisor was 5m cubed, right? So its power is 3. Our remainder, what's left over, is 10m, which really means 10m to the power of 1, so its power is 1. And since 1 is less than 3, we can't divide anymore. That's it. That's our big red stop sign.
So there you have it, polynomial division. It really just boils down to simple division, that one little power rule, and a clear signal for when to stop. It's a logical, repeatable process, which kind of makes you wonder, right? What other math puzzles out there that look super scary are actually just simple problems waiting for you to find the right key to unlock them?